Today's Daily Dose of Math is about Pythagoras Theorem. Let's look at some easy examples of using Pythagoras. In my examples, I'm going to call side A the shortest side, and side B will be the medium length side. I'm calling the hypotenuse side H. So in this example, we know A and B, we know that they are 6 and 8, and we can replace in the formula a squared with 6 squared, b squared is replaced with 8 squared. Now we can find our hypotenuse, which is the x. 6 squared is 36, 8 squared is 64, and 36 plus 64 is 100. So h is going to be equal to the square root of 100, which is 10. I'm not bothering with the unit of measure for these examples. So we found our unknown, and our x was our h in this case. In this second example, I know the hypotenuse, but I know the a and not the b, so it's the b that I'm looking for. A squared is therefore 3 squared. I'm going to change b squared into x squared. It doesn't matter what variable I use. And h squared is 5 squared. 5 squared is 25, 3 squared is 9. Now, we need to isolate our unknowns, so we're going to move the 9 to the other side, where it becomes negative. 25 minus 9 is 16. If x squared is 16, x is equal to the square root of 16, which is 4. I have my answer. In the third example, a is the unknown, so I'm going to replace a with x, and b is replaced with the 12, h is replaced with the 15. 15 squared is 225, 12 squared is 144. I have to move the 144 to the other side, so we have 225 minus 144, which is 81. X is equal to the square root of 81, which is 9. I have my answer. Now we get to this special example. This is an isosceles triangle. These little lines are telling me that these two sides are the same size. But what's strange about this is, usually to use Pythagoras Theorem, we have to know 2 of the sides. And then the other side is our unknown. We're able to solve for it. But here we only know one side, which is the hypotenuse. And we have 2 sides that are unknown, but we know they're equal to each other. So A is equal to B. If A is equal to B, then I can call both of them A if I want, or I could call both of them B and it wouldn't matter. What I'm going to do is I'm going to call both of them X. So our formula becomes x squared plus x squared equals h squared. And the reason that we can solve this, even though we had 2 unknown sides, is because x squared plus x squared can be combined into 2x squared. At this point, I'm going to replace my h with this value, which is 10 root 2. I'm writing 10 square root of 2. I'm going to put a bracket, and I have to square it because of the formula. 10 root 2 squared is equal to 10 squared times root 2 squared. 10 squared is 100. And root 2 squared is 2. The square root of 2 times the square root of 2 is 2. I have 2x squared equals 200. Now I have to take care of this 2. Algebra allows me to divide both sides by 2. These cancel. X squared is equal to 100. Therefore, x is equal to the square root of 100, which is 10. I have my answer. So even though I had 2 unknown sides, I was still able to find the answer because those 2 unknown sides were equal to each other. It gives us an extra little trick that we can apply to do an even more complicated version of a Pythagoras problem. And we can still solve it. Another question is, why did I use this weird number, 10 root 2? Because I wanted my answer to be a whole number and not some weird decimal. And because the 10 root 2 had to be squared anyway, the root 2 times the root 2 turned into a 2, and I avoided having ugly decimals that make the example look more confusing. That is today's Daily Dose of Math. Please subscribe and hit that thumbs up button.